Hello everyone, this is another question from this GTA series, and this question says that there is a parabola omega y square is equal to 4x. Means there's a omega is a parabola, y square is equal to 4x is the definition of it or the equation of it. A point p h comma k moves on the circle. The circle is h square plus k square is equal to 5. If two distinct real tangents can be drawn from P to this parabola, they touch omega, the parabola, at A and B. Let RP be the bounded region enclosed by PA and PB and the parabolic arc AB. And if SP denote the area of the RP, then we have to find out the maximum possible values of the SP. So read the question carefully again and try to solve it. Pause the video and then you will see the solution that will be better. So what we can do here, let's first draw the diagram and try to understand what the question is demanding. So for that I have to first change the color. Wait. Okay. So let's draw the diagram first. So this is the diagram we want to draw, and what they're asking, let's see first. This is the point P on the circle, this point P on the circle. It means this is on the circle like this. Circle has the center at origin and the radius is root 5. So the circle will be like this, and from that point on the circle we are drawing the two tangents on this parabola. So I've taken one location of such point, and it doesn't matter if you draw the circle or not, but you have to keep in mind that this is a relation between h and k is given. H square plus k square is equal to 5. After that, what they're saying that the PA is a tangent, means A the point of tangency and B is also another point of tangency. And we need to find out the area of this region. You notice again, reread the question. You will come to know that this is the area they're actually asking for, means this entire area from here to here. See, the question is saying that RP be the bounded region enclosed by PA, PB and the arc AB. So this is the area they were looking for. If SP is the maximum of that area, we have to find out that possible value. So first of all, there is a property hidden here. They are asking that property. If you don't know the property, you can just learn it here, and the proof of this is very lengthy and this is not the scope of this video. If you know the property, that's better. If you don't know, you can apply different thing. I will tell you. So better you learn the property and understand this thing. So the property is this one. If there is a point from where I draw the two tangents, this PAB will be a triangle, and this PAB triangle is actually deciding this area outside of the parabola and inside the triangle, and again one area inside the parabola with the triangle, means in the triangle. I mean to say that this is the area, we have this part, area, this part, and the whole triangle area. And the property is this is actually very important note, and they will be beneficial for the students who are actually entering in the class 12th, and maybe they are preparing for this examination and they are still learning the parabola and all these things. So the note is that the area of the triangle APB rather, ABP is thrice of the area of, let's say this area is R, and let's say this area I call it let's say T. So thrice of area of R. It means that the area what we are looking for, or let me just say in this way, the area R is to T is to the total triangle APB is actually 1:2:3. What I mean to say, if the area of the triangle we have So I can say the area RP is actually 1/3 of the triangle area APB. So if we are looking for the area of this region, the R, it means if we are finding the area of triangle, we can make the 1/3 and our work will be a little bit convenient. If we don't know this property, then we can use this technique. What we can do, use this thing, we can draw a perpendicular line here, means the line parallel to the x-axis. Again, we actually create like this. Let me just draw it. So suppose you draw a line like this on edge, and again we try to construct these two triangles with this P and B. So this is perpendicular, we have to assume, and we find out the area of under this parabola or left to this parabola from the y coordinate of this B to y coordinate of A. So we'll get this total area, and we subtract these two areas of this triangle and this triangle together. Then we get this area back. But this is a little bit cumbersome. If you know this property, that will be easy. If you don't know, then we have to do this. There's no other way. All right. Or maybe I don't know the other way so far. So if you know this area, this property, by the way, you can use this fact. How do we use it? Let's see. Suppose I have to find the area of triangle PAB. What we do? We drop a perpendicular from P to this chord AB. If you drop the perpendicular, now the area of triangle APB, I can write, is the half into base. The base is going to be, let's say perpendicular is this PM. So the base is AB and the PM is the perpendicular length. So that is nothing but 1/6 of AB into PM. So all that we have to discover what is AB and what is PM. So let's try to discover it. And how do we discover it? We'll do it here. We know that this is actually the point h comma k, and from there we are dropping two tangents, and on that point of tangency there is a chord. So that chord is going to be the chord of contact. So chord of contact equation is t is equal to 0. So it means I have this 2 it means I have what? The equation was y square is equal to 4x. So what I write? y1 and 2x plus x1. And that is going to be 2k and twice of x plus h. So this is the chord of contact we got. This is the equation of AB. And now our work is to find out that length of perpendicular. So length of perpendicular, how do we find? We know that this we can write as 2k minus 2x. And why I have written 2k there? That should be yk. Sorry for that. So the yk minus 2x minus 2h is equal to 0. And we are dropping the perpendicular from the point h comma k. So that will give you k squared minus 2h minus 2h divided by k squared plus 4 square root. So this is our length of perpendicular, which is actually the PM. We got the PM also. Now I have to find out the AB. How do we find the AB? Let's see. You notice that in order to find AB, I can find out the, let's assume that's what. Okay. So what I'm going to say, that this is actually the formula. We don't have to care about this. So I'm just crossing it, otherwise you'll get confused. Why you can get confused? Let me just reveal it. You can, I'm just taking this point as x1, y1, and this point B is x2, y2. So of course we don't have to assume this as x1, y1 and x2, y2. So that's why I'm not using this formula I have it. Okay. So to find the AB, you not use the distance formula? Yes, we can. So let's find the AB. How do we find it? It is going to be x1 minus x2 the whole square plus y1 minus y2 the whole square. So instead of finding this entire situation, like x1 entire situation means, so instead of finding the points A and B, we can use some smarter way. What the smarter way is there? Either we can take x1 minus x2 common, and or we can take y1 minus y2 square common. So we'll save it and see what I have to take common in a moment. So let's find out the points A and B. How do you find it? Let's create an equation. I have this equation, you know that y square is equal to 4x, and I have this equation second. I have to solve it to get an equation in terms of y or x, whatever be the convenient for us. So from 1 and 2, at what I'm writing, from 1 and 2, what I'm writing is that, see here, this y squared I can write as 2 times 2x, and this 2x I can write from here. What is 2x? 2x is yk minus 2h. So I'm just replacing there 2 times yk minus 2h. And in that way, what will happen? You get a quadratic in y actually. So y square minus 2ky minus 2ky and plus 4h. So that is our quadratic equation we got. So this quadratic equation, we have two things. The first is y1 plus y2, that is sum of roots, and that is going to be 2k. And the second is y1 into y2, that is the product of root, that is 4h. Then I will find y1 minus y2 is will convenient. What is that? Square root of a plus b the whole square minus 4ab. Correct. So what we get it here? That we get it. This is going to be 4k square minus 4 times 4h. So we get it here twice of root over k square minus 4h. So that we got y1 minus y2. So again we take this AB and see what is convenient for us. So let's take it. So AB I have now. I'm taking y1 minus y2 common from there. So we'll come at y1 minus y2 mod. And in the square root, what we get it here is x1 minus x2 by y1 minus y2 the whole square and plus 1. But notice x1 minus x2 by y1 minus y2 is the reciprocal of the slope of the chord, because you are connecting this a and b to find out the chord, and since we are taking the ratio of the difference of x coordinates by and the difference of y coordinates is the reciprocal of the slope of the chord, and here is the slope of the chord is actually going to be, what is that? The slope of the chord is 2 by k. So what I'm going to do is, slope of chord is 2 by k, so that will become k by 2. So y1 minus y2, I'm going to write this thing twice of root over k square minus 4h, and here I have the chord slope was 2 by k, so that will become k by 2. So it will become k square by 4 plus 1. And then we simplify what we get it here, k square minus 4h, and this 4, and you notice that this 2 will get cancelled. So what I'm getting k square minus 4h here, and here I'm getting k square plus 4. This is AB, and we have already found the PM. So let's substitute this two things in this area. So area is AB into PM. I have already marked this PM here, and this is AB here. So area is going to be what? The area, what is the area? R of P is going to be 1/6 of this quantity. This quantity is also, notice that k square minus 4h divided by root over k square plus 4. So I'm writing this thing. So k square minus 4h divided by root of k square plus 4. And here again root of k square minus 4h and into root of k square plus 4. You notice this 2 will get cancelled, and we have a little bit cleaner version of this area in terms of this. So what we get it here, k square minus 4h to the power 3 by 2. This is the area function of the required region. Now this k square minus 4h, that's all I have to maximize, because this 3 by 2 is nothing to do with the maximum or minimum. This is only giving the value. So what we do, we have to maximize this k square minus 4h. So I'm just calling this as a new function f, and I don't know, it is a function of k or h I will create, so I'm calling it k square minus 4h. Now remember, I had the h squared plus k square is equal to 5. So it's convenient to substitute k square as h square 5 minus h square. So now we'll turn into a function of h, and this will going to be 5 minus h square minus 4h, and this is a pure quadratic. Negative h square minus 4h plus, sorry, yes, plus 5, and this is a ulta kind of a quadratic, means it's an upside down parabola of this quadratic equation. So the maximum will reach when h is equal to minus b by 2a. So h is equal to minus b by 2a means minus of minus 4 by 2a by 2. So that is going to be 2. Oh, this is also minus 1, sorry. 2a means minus 1. So it will be minus 2, sorry. So that is going to be minus 2. So h is equal to minus 2 we got. And what is the value at minus 2 of this function? So f minus 2 is going to be minus of minus 2 squared minus 4 times minus 2 plus 4, 5. Let's calculate it. So that is going to be minus 4 plus 8 plus 5. So that is going to be 9. So I got the f minus 2 value 9, and that is h value is minus 2. It means I have to find this maximum of this. So let's just substitute this minus 2 there to find the k value, correct? Why I found this thing, I don't know. Wait, f of minus 2, what is the need of it? Okay, I don't think so they need. Okay, but by the way, one thing also have to keep in mind that the h square plus k square is a 5. It means that I have to have on the circle. So circle has the radius negative root 5 to root 5. So maybe there is a chance that we created quadratic for our convenience, and the points it is spitting out is not on the circle. So you can see that this value minus 2 is actually lying in the interval. So it can be here also, or it can be here also. Means x coordinate will be minus 2, so it will be anywhere. Now if x is equal to, or h coordinate is minus 2, so what is the k? So k will be what? K square is equal to 5 minus 4, that is 1. So k is equal to plus or minus 1. It means the 2 points will be minus 2 comma minus 1, or sorry, plus 1 and minus 2 comma minus 1. Now that these two values h and k, we have to put it this in this actually, and then that will be the maximum. Yes, if I'm missing anything, no. Let's see. So k is equal to 1. So 1 minus and minus 2, that is 9. 8, sorry, 8, not 9. I calculated in mind the total or overall value. So 1 by 6, and this is 9 to the power 3 by 2. So 9 to the power 3 by 2 is going to be 27, I think. This is going to be 3, and 3 to the power 3 is 27. So 27 by 6. So what I'm getting is 9 by 2. Is it there in the option? 9 by 2 is the third option, and that's the answer. So this is one way to do it. I have also done this question. I tried it by solving this one, the area of finding the area left to this parabola, and when I got the expression, then suddenly it came to my mind that there's a property is there. Honestly telling, in the first go when I saw this question, it didn't suddenly click to me that we have to apply this property. First I tried, and in between only I came to understand that over this property we can use units and so on. So the entire thing is actually relying on this property. If you know the property, it will be a little bit better and little bit faster. Otherwise, you have to go by the integration technique, and again you come to the same conclusion that the area will come out to be in this format. The other remark I want to make is this: because the parabola, ellipse and all these conics have variety of different points, means there is a parametric point also, there is other slope version also. So this can be also written as the t, and like a parameter, like x equals to t and y is equal to 2t. So from there also, x equal to t square and y is equal to 2t. So from there also we can get the same kind of a structure, and we get the same area in terms of the t. The other thing is that suppose you want to use the slope form. In the slope form also the m will come into the play. But I think that without going into t, parameter and slope, it will be convenient to take our usual thing. There is less chance to get mistakes. Alright, so that's all for today's video. See you in the next video with some other interesting question. Stay math active.